I'm Matthew Hall at Bromley Emergency Courses, and in this short video tutorial, part of our series of videos helping candidates prepare for the FRCEM Primary Exam, I want to talk about the immune response, and in particular about innate immunity. Now, some degree of knowledge about the immune response is required for the FRCEM Primary Exam. It features in the RChem Basic Sciences curriculum under the Pathology section, section 5.2. And while you don't need to know everything about the immune response, it is, after all, a remarkably complex area. Experience with the exam does show us that certain areas are examined, and innate immunity is amongst them. First of all, let's just look at the immune response overall, and we can divide it into two main divisions. There is innate immunity, which we're going to talk about today, and adaptive immunity, which we may do some video tutorials on later. Innate immunity has a number of components. It comprises the anatomical barriers to microorganism entry, as well as non-specific molecular and cellular responses to potential pathogens. What do I mean by non-specific? I mean, in order to activate innate immune responses, recognition of specific antigens is not required, and innate immune responses simply recognize that potential pathogens are present in order to upregulate and mobilize against them. Innate immunity is rapidly mobilized, acting over hours, and is also intimately linked with acute inflammatory processes. In contrast, adaptive immunity is a specific response to certain pathogen and pathogenic antigens. It does require antigen recognition, and it also involves immune cell proliferation, and in that we mean B cells and T cells predominantly. But adaptive immunity is slow because it requires clonal expansion, proliferation of lymphocytes. The response takes days to reach maximal efficiency. So a simple way of looking at these two systems is that innate immunity provides the rapidly mobilized first line of defense against potential pathogens. But once pathogens have got round innate immune responses, entered the body and established a foothold, then the adaptive immune response must be activated and mobilized to deal with the established and active infection. So what are the components of innate immunity? Firstly, let's talk about the physical or anatomical barriers to microbial invasion. Foremost is the skin. The watertight keratinized epithelium, which covers most of our body surface area, prevents microbial entry, providing, of course, that it is intact. The mucosal surfaces of the body, however, are not keratinized and are significantly more porous to invading microorganisms, and have therefore needed to develop further protective mechanisms to prevent microbial invasion. Often overlooked is the washing or flushing effect of the various mucosal secretions. For example, tear fluid washes the surface of the conjunctiva every time we blink. Saliva is continually produced and washes the oral cavity. The flushing action of urine down the ureters and the regular voiding of the bladder helps maintain the sterility of the urinary tract, while we know that biliary obstruction with perhaps gallstones predisposes towards biliary infection because it inhibits the flushing action of bile through the bile ducts. Mucosal surfaces are also bathed in antibacterial secretions. Those secretions contain chemicals such as lysozymes and lactoferrin. Lysozyme is an enzyme which degrades peptidoglycan, a component of bacterial cell walls, whereas lactoferrin sequesters iron. Bacterium require iron for their replication, and so removing iron from their immediate environment is inhibitory to their growth, and that's the role of lactoferrin. Also in mucosal secretions are phospholipases, inhibitory fatty acids, and secretory IgA, which we'll talk about in a moment. But think also about the mucociliary escalator of the respiratory tract, that constantly beating cilia which moves bacteria, debris, and so forth, constantly moving it upwards, trapped in mucus, towards the oropharynx for expectoration. And the acid environment of the stomach, the low pH, less than 1 or 2, is quite bactericidal, and few microorganisms can survive its harsh environment. In addition, the normal commensal flora of the GI tract suppresses overgrowth of any one organism. The vaginal mucosa is similarly defended with an acid environment in commensal flora. Secretory IgA deserves a special mention. It's a type of immunoglobulin which also has a secretory component which prevents its degradation in the mucosal environment, and secretory IgA is found on the skin and on all mucosal surfaces. It is able to recognize invading microorganisms and flag them up to local immune cells, as well as being a weak activator of the complement system, and as such plays a role in initiating the molecular and cellular components of innate immunity. So let's talk about those non-specific molecular and cellular responses that are part of the innate immunity. Very important is the complement system. Complement proteins are able to recognize invading microorganisms, particularly bacterium, by recognizing proteins on their cell wall and capsid. Activated complement is very pro-inflammatory and triggers a local inflammatory response. In addition, other complement proteins are able to combine into a membrane attack complex. This inserts into bacterial cell walls and lyses the bacteria, effecting direct cell killing by the complement system. Further complement proteins are able to opsonize, that means coat bacterial cells with complement protein, which makes them much more attractive to phagocytic cells for digestion. Furthermore, certain effector cells are attracted within hours to the site of microbial invasion, and these are able to kill invading microbes by phagocytosis. Such cells might recognize potential pathogens because they have become coated with either complement or IgA antibody. Foremost in these effector cells are the polymorphonucleoleucocytes or neutrophils, but also monocytes and macrophages can act as part of the innate immune response. A third type of cell, the natural killer cell, also upregulates its activity, and these cells are able to lyse virally infected host cells as well as some tumour cells, not by phagocytosis but by inserting membrane channels called perforins. So that is our quick run through innate immunity.